Jai Jendra, Namaste. My name is Sayyam Jain. Welcome to my channel. Today we are going to solve the 8th question of the problem solving series that is based on arrays. And this question has been asked in multiple companies like Google, Facebook, Amazon. And the difficulty level for this question is medium. So we need to find the sub-array with given sum. We are given an array, the length of the array and the sum. We need to find the sub-array whose sum is equal to the given sum. In the previous question we have discussed about subarray. We solved the subarray question. So subarray is a part of the array which is contiguous. So here in this array, is there any subarray whose sum is equal to 33? If we take the sum of 1 plus 4 is 5, 4 plus 24 is 24. If the sum of 23 plus 4, 27, 28. So 20 plus 3 plus 10, 33. So this is the subarray whose sum is 33. So we need to return yes, or the question also could be that find the starting and the ending index of the subarray. If we have to return that, then the answer would be from 2 to 4. 0, 1, 2, 3, 4, 5th index. So from 2 to 4 is the subarray whose sum is equal to 33. Here the subarray whose sum is equal to 3 is 7 is from index 0, 1, 2, 3, 4, 5, 6. From 1 to 4. And yes. And here we can't have the subarray with sum 50. So the answer is no, or minus 1. So how do we solve this subarray question? Let's discuss the brute force approach first. So here if we traverse the array with two loops, nested loops, then we can find all the subarrays, and we can check if any of the subarray sum is equal to the given sum or not. So if we start from here, I is equal to 0, if this is fixed, j is equal to I plus 1. So from 1 plus 4, 5, 1 plus, it's not equal to 33, 1 plus 4 plus 20, 25, everything will change, I will increase. And for example, this case, I will become 2 and j will become 4. So we'll have the sum variable already, so 20 plus 3, 23 plus 10, 33. So sum would be equal to 33, the given sum, and we will return the index of 4 and index of j, I and j, and we'll get the answer. So what would be the time complexity for this? The time complexity would be order of n square for nested loop. Nested loop, order of n square. Do we have an optimal approach? Can we solve it in order of n? Can we optimize it? Yes, we can optimize it, and we will learn a new technique which is called sliding window, which is a very popular technique. We will be solving more questions on this. The technique is sliding window. So let's understand this. Let's take the second example. Suppose if I am taking this number, I am traversing this array, and here the sum is 1. The first array is A0. Okay. Now, if suppose I am traversing from I equal to 1 to this n, the sum is 1. If I add this 4, what would be the sum? Sum would be 5. Is 5 less than the sum given? No. What does this mean? That we can add more elements to it, right? And okay. So firstly, this the array will have non-negative elements. This is mentioned in the question. Okay. So since the array will have non-negative elements, we can add more elements, more numbers to it. The sum is less. So if we add 0 over here, so what would be the sum? Sum won't change. 5 plus 0 is 0. Again, if we add 0, 5 plus 0 is 0. Now if we add 3, what would be the sum? From here we have started. From here till here, the sum would be 8. What does this mean? The sum has crossed. So we can't take 3 or we can't take any elements. So what can we do? So the name itself is a sliding window. We are sliding and we see that we have crossed certain length and that length is suppose sum and we can't cross it, then we can minimize this length from this side, right? Because here we are not going to get elements. So what we will do, we will reduce the sum, current sum we'll do current sum minus the index from which we have started. So what will happen? Our sum would become 5 minus 1. That would be 4. Now the sum is 4 and we are over here. And now if we include 3, what would be the sum? Sum would be 7. We have got the answer by removing this element. So this is the subarray. Will this work for all examples? Of course it will work. It will get all the sums. Let's do it for this one. So we have the sum as 1. We are starting from 4. So 1 plus 4 becomes 5, less than 33. 5 plus 20 becomes 25, less than 33. 25 plus 3 becomes 28, less than 33. 28 plus 10 becomes 38. That's more than 33. What we are going to do? We are going to slide it. So 38 minus 1 would be 34. That is the sum. Or 37. 38 minus 1 would be 37. That is the sum from here to here. Is 37 greater than 33? Yes. Then again we will remove this element. So 37 minus 4 would be 33. And 33 is equal to the sum that is given. And that is our window. Right? So this is the approach. Let's code it. So we'll have int current sum as say a0, and we need any other things? So we have everything, right? Current sum equal to, okay, we need the starting index. Starting index start equal to 0, right? We will start from 0. Then we will traverse from I equal to 1 to n. Okay. Suppose the first element itself is greater than the sum. So we will not add it. We will check in the beginning itself that if the current sum is greater than sum, and if say start will always be less than n, I minus 1, right? Start will be always less than I minus 1. So start is less than I minus 1. Then in that case we will include it. Okay. We will exclude this because it has, if the sum is greater, we will slide it from here. In the beginning only we will check. So current sum will become, current sum is equal to current sum minus a. So let's write this minus a of I. Okay. If current sum is equal to in the beginning itself is equal to sum. So what we will do in this case, if it is just to say whether the subarray exists or not, then we will return 1. Otherwise, if we need to return the index, then we will just maybe print, or maybe we can return, it's an int, right? So we will return 1, and we will also print, say, that sum exists from what will print the starting index, and what will be the end index. End index will be the index which we are at, and we will return 1. Okay. If current sum equal to this, else if, let's do it else if both the condition is not there, then what does this mean? That the current sum is less than sum. So if current sum is less than sum, that means we can add current sum plus equal to AI, and we can write, so the starting index, current sum equal to sum, and here we have missed this. Since we are subtracting the element, the beginning element, so we will not start from that element, right? So we have to do start, the start index would increase, right? Here this should be added, and in this case we are just adding the current sum, so we don't need to do any other things. Here the current start will be added because we are excluding the beginning part, because the current sum is greater than the sum, so we will remove it, and then this loop will be closed. And if we don't find any, if we don't return one, that means there is no element that has the sum of the Subarray equal to the given sum. So the time complexity for this will be order of n, and space complexity will be order of 1 in both the case. The link to the question has been given in the description. Let's go to try it yourself, and let's go to the code walkthrough. So here is the code walkthrough of the 8th question. Find the subarray with given sum. Here we have to return the vector of we have to return a vector with the starting index and the end index of the subarray with the given sum. Also, it is mentioned that if we don't find the given sum, then we have to return the vector with only one element as -1. So we have already discussed the code. We are taking the vector and we are traversing the array, and we have already assigned it with the first element, and if the sum is greater than the sum given, then we will be incrementing, we are adjusting the windows, we will incrementing the start. And here I think in the while explanation I have given if, but it would be while, because for example here if the sum if this 7 is 17 and the sum that is required is 19, so if we sum it over here as 1 plus 2 3 3 is less than 19, 6 is less than 19, and then 17 plus 6 becomes 23, 23 becomes greater than 19, then it comes over this condition and we will be subtracting. So we will be subtracting 1, then it becomes 22, 22 is still greater than 19, that's why it should be while instead of if. So again we will be subtract, we will adjust this starting window. So 22 minus 2 would become 20, and then 20 minus 3 would become 22 minus 3 would become 19, and we need the sum as 19. So this condition won't be satisfied, it would come over here, and then we will break it and we will store the starting index and the end index. End index would not be, starting index would be start plus 1, because here they want it from the they are considering the indexing 1 based indexing while returning. So here in this case this is the sum, 2 plus 3 plus 5 7 12. So the answer is the second index and the fourth index. But in the end index we will be giving only I only, not I plus 1, because we are adding the sum of the array element to the current sum after doing this all check. At the end we are doing this. So this would be the solution, and this is the edge case. If x is equal to 0, then we'll be returning the vector with -1. So let's compile and run it. Though we are we can see there is a nested loop, but still the time complexity would be order of n only, because we would not be traversing it till the n square times. It will be traversing it n times only. We can calculate it. So if I submit it, this works fine. So let me know how was my explanation, if is the question clear or not. Shall I make another video on this if it is not clear? And the time complexity and the space complexity is already discussed. Space complexity was order of 1. You could have done with it with map also, but then the complexity would be space complexity would be order of n. And this is the way we solve the problems with sliding window. We'll be solving more questions on sliding window. So let me know how was the explanation in the comment section, and we'll be solving the 9th question of array in the next video. Jai Hind.